So we are on the Chapter 10 Unit Test Review Packet. And we're going to start by solving some systems by graphing. So real simple, just graph both equations and see where they cross. The point that they cross will be the solution. So x equals -4, that's the line that is always on x equals -4. So you go to the x-axis and you draw that line at -4. And y equals 1/2 x minus 2, you're starting at -2. It's a positive slope of up 1 over 2. So as we look for the intersection, we're going to work our way this opposite direction, down 1 over 2 to the left. And the point of intersection is our answer, which is -4, -4. Number 2, starting at -1, slope of up 1 over 2, going the opposite way, down 1 over 2. And there's that line. And the second line, starting at 4, has a slope of 3 over 1, so up 3 over 1. I'm going to work my opposite way, down 3 over 1. There's my intersection. And so that's the point, -2, -2. Okay, number 3, I can't plot these on the graph until they are in y equals form. So I'm going to minus 3x from both sides here, leaving me 2y on the other side, -3x plus 2 divided by 2. So y equals -3/2 x plus 1. So if I go to graph that, I'm going to go to 1. And I'm going down 3 over 2. Going the opposite way, up 3 over 2. And my other equation, I'm also going to minus 3x from both sides. So I have 2y equals -3x minus 2. I'm going to divide by 2 across. I have the same slope, so that tells us something. My intercept, though, is -1. So I'm hitting at -1, and I'm going down 3 over 2, up 3 over 2 this way, up 3 over 2 this way. And because they have the same slope and they have a different intercept, these are parallel lines. They're never going to touch, and so there is no solution here. Okay, number 4, we're going to minus this x. When we do, we have to make sure that we keep that negative with the y, and we're going to have to get rid of it before we can graph. So we're going to divide by -1. So it becomes positive 2x, positive 1. So starting at 1, slope of 2 over 1. So up 2 over 1, up 2 over 1, opposite direction, down 2 to the left 1. And this one, we're going to minus x, and we're going to immediately be in the form that we want, y equals -x minus 2. So we're starting at -2. This is a slope of -1, which is -1 over 1. So we're going down 1 over 1 with this line. And so if I go the opposite way, up 1 to the left 1, you can see it's going to follow this line. And the point of intersection is -1, -1. So on number 5, we're dealing with some inequalities here. So we have shaded regions because it's all the values less than or greater than a line. So starting here, we still need to graph them the same. We're starting at 1. Slope is -1/3, so down 1 over 3, down 1 over 3. Going the opposite direction, up 1 over 3, up 1 over 3. Looks like that. And with these, we are either going to have a solid or a dotted line, and because there's no equal sign on this, these are dotted lines. Okay, and the next one already in nice y equals form, so we're starting at 4 and going up 2 over 3. Down 2 over 3, there's our intersection. This one also is going to be a dotted line. And now we're looking for our shaded region. So if I go back to my first one that hits at 1, it says y is less than. So that means it needs to be underneath this line, underneath it. So it could be this region or this region that we're going to shade based on whether it's greater than or less than this line. This one says less, so it needs to be under this line as well. So we shade the region that is under both lines at the same time. So we can't shade this because while it's below this, it's not below this line. This region down here is less than both of those lines. Number 6, think of this like x equals 2. That's the line that goes through the x-axis at 2. And no matter where you go on that line, the x value is always 2. This one should be dotted, so my mistake there, but it should be dotted because there is no equal sign. The second one will be solid. Starting at 5 and going up 1 over 2, you can see there's our intersection. Down 1, left 2 to go this way, and this is going to be a solid line because of the equal sign. Now this says x greater than, so if you look at the x values, they're greater than this line to the right, they're less than to the left. So my shaded region is going to be to the right of this line, so it's either this region or this one, depending if it's greater than or less than this line. This one says less than, so less than this line would be underneath, which means this is my shaded region. 7 and 8, we have to do some rearranging. So we're going to minus 11x on both sides. That's going to leave me negative 2y. When I put it on the other side, it's negative 11x minus 16. I'm dividing by a negative, and when we're dealing with our inequalities, we need to make sure anytime we divide by a negative, we flip this. So y becomes less than or equal to. 2 negatives make a positive. We can drop them. We're going to leave it as a fraction. That's our slope. This is positive 8. So we are starting at 8 and going up 11 over 2, right, way up over here. So when we work the opposite way, we need to go down 11 and to the left 2. So down 11 gets to here and 2, and those are the only 2 dots we're going to have. Oh, and that should be a solid line. This one we're going to minus 5x on both sides. So we have 2y less than or equal to, now it's negative 5x minus 16 on the right. We're going to divide by 2. We're dividing by a positive, so there is no flip. It stays less than negative 5 over 2x minus 8. So we are starting at negative 8, and we are going down because it's negative, down 5 over 2, which puts us off the graph. We need to make sure we're working our way this way, so it's a negative slope. So we're going to go up 5 over 2, which is going to hit right here. 1, 2, 3, 4, 5, 1, 2. This is a solid line. And you have to look at your final answers here to deal with your shading. Less than, needs to be less than both of them. So if you see this one hits at 8, so I need to shade on the side that has the y values less than 8, which is this side of the line. And here my y value is negative 8, and it says less than. And so again, I need to shade underneath this line where the y values are less than. And so this region out here is less than this line, but it would be greater than this one. This region out here would be less than this line, but greater than this one. And this section right here is less than both of those lines. Number 8, we can put this one right on. So we're going to y equals 1, and we're drawing a line, and it's going to be solid. It says less than, so we will be shading all the y values less than this, but it also needs to match the other one. So minusing 4x from both sides here. It's going to leave me negative 3y. Don't lose that minus sign. Greater than or equal to negative 4x plus 21. Divide by negative 3. And that's very, very, very important because we need to flip. So y becomes less than or equal to. This is a negative 4 divided by negative 3, so positive 4/3 x. Positive 21 divided by negative 3 is a negative 7. So we are hitting at negative 7 and going up 4 over 3. There's our intersection. Solid line. And we already said we were shading underneath this one because the y values that are less than 1 are underneath. So we could be here if it's greater than this line, or we could be here if it's less than this line. Final answer says less than, so that is underneath. You can always double check at your intercept. It's at negative 7. The y values less than that are on this side of the line, so we need to be shading on this side of the line. Okay, so for these nonlinear equations, we're going to go ahead and graph them and find the intersection. We're going to do it on the graphing calculator, so we're going to go to our y equals and plug this in, including our parentheses. Raised to is right here. So the third, scroll over so that we're not adding to the exponent. We're doing separate over here, minus 4. So it should look like that. And then the next one, should look like that. So if I go ahead and graph these, I'm in standard zoom right now. Let's see, I've got one intersection there. Now if I want this graph to match, I need to make sure my window is 1 counting by ones, which it should be if it's in standard. But my intercepts, I'm sorry, not my intercepts, my y minimum, y maximum, x minimum, x maximum on this graph, the one that I have to draw this on, are 8 and negative 8, where my standard window here is going to be negative 10, positive 10. So I'm going to put in negative 8 and positive 8 for my x minimum and maximum, and my y minimum and maximum. Scale of 1 is accurate. Okay, we're counting by ones. So now if I go back to my graph, it's going to look very similar, but I can get a much more accurate sketch now. Okay, so I've got this one swooping down over here. This comes up and we'll cross once. And so we're not going to try and just based off our sketch pick this point of intersection. We're going to do it right on the graph. So to get to the calculate function, you hit second and the trace button. And we want to know where do they intersect. That's number 5. Calculator will ask us to identify which two curves we're trying to find the intersection of. So right off the bat here, I don't see the cursor, so I'm going to scroll sideways. There it is. Okay, so my first curve I'm going to call the red one. Second curve I'm going to call the blue one. If you did that opposite, it doesn't matter. And now where it says guess, I need to scroll over close to that intersection and hit enter. And my answer here is negative 2, 4. All right, we can go back to my y equals here. You can see this graph is different. My minimums and maximums now are 10 and negative 10, and I'm counting by 2s. So I will have to go adjust my window. First, let's throw these in here. So it's x raised to the 8th. And I'll just go ahead and match this up and put it up here. So x raised to the 8th. And then negative x, you need to make sure when you put in negative x that you use the negative button, not the subtraction button. So negative x. And before I hit graph, I'm going to go change my window. All right, I'm going to make this negative 10, positive 10. My scale is counting by 2s. Okay, negative 10, positive 10 for my y min and y max. Scale again of 2. So when I go to graph this, my graph now looks like this one. Okay, and it looks like we've got 2 intersections. It's going to slice right through the corner here somewhere. Good enough for that. Now let's go ahead and find those intersections. So first curve, yes. Second curve, yes. For my guess, I'm going to scroll over close to one of them. And that is negative 1, 1. I'm going to do it again. Second, calculate. 5 for intersect. First curve, hit enter. Second curve, hit enter. For guess now, I scroll closer, hit enter, and it tells me that it's 0, 0. All right, moving on. Solving by substitution, meaning I know what y equals, this whole expression, so I can plug that whole expression in for y in the other equation. So 6x plus 14 is substituted in for y. The rest of the equation remains unchanged. And now I'm going to go ahead and solve it. X on both sides, get rid of the smaller, so I'm going to add 5x. It's 11x. Minus 8 comes down as a negative 8. Now I'm going to minus 14. So 11x equals negative 22. Divide by 11. X equals negative 2. I got to find the y value as well, so I'm going to go back and plug into one of these. I'll take the second one. There's no negative. So it's 6 times my answer of negative 2 going in for x, substituting in. So y equals negative 12 plus 14, so y equals positive 2. Final answer should be written as an ordered pair, the x first, negative 2, 2. Okay, number 12. Again, we have one of the equations in y equals form, so that's what y equals, 4x plus 24, which means I can substitute that expression, 4x plus 24, in for y in the other equation. So I rewrite the entire equation, but substitute in for y, so 4x plus 24 drops in. And now I'm going to solve it. So I need to do some distributing. Negative x remains unchanged. This is a negative 2 when I'm multiplying, so that's negative 8x, and that is negative 48. Combining here, they're on the same side, so I'm not subtracting in 2 spots, because if I do that, it's once on the left side of the equal sign, once on the right. They're both on the same side, so I'm combining. This is a negative 1 and a negative 8. That's a negative 9x. And to solve it, I'm going to move this 48 over. So negative 9x equals positive 45. Divide by the negative 9. X equals negative 5. Go back and plug in. Now you can plug into either one. I would plug into the second one. It's easier. So 4 times negative 5 plus 24. That's negative 20 plus 24. That's 4. Final answer as an ordered pair, negative 5, 4. Okay, down to the bottom. Elimination. We're combining the equations together, adding them together, trying to get something to eliminate, one of the variables to eliminate. Sometimes it's set up for us, sometimes it's not. This one is. My x's will eliminate each other when I add them together. So 7x and negative 7x cancel. Negative 2y and positive 2y also cancel. So on this side of the equal sign, everything has gone away. I need to fill that space with a 0. And 6 minus 21 is negative 5. That is not a true statement. 0 does not equal negative 5, so there's no solution here. 14. Right now I am not set up to cancel, but I do have a 4 and a 4. So if one of them was negative 4, these would cancel. So what I'm going to do is I'm going to multiply this whole equation by negative 1, and that will create something that cancels. Now you could have multiplied this one by negative 1. It does not matter. One of them, though, does need to become a negative. So I'm going to go ahead and distribute here, make sure all 3 get it. So negative 4x. This is negative times a negative, so positive 6y, negative times a negative, positive 18. X's cancel. So this is a negative 1 plus 6, that's a positive 5y. And this is 25 when I add them together. So divide by 5, y equals 5. The y does, not x, y does. So I'm going to go ahead and plug into one of these. I'm going to choose this one, substituting in for y. So solve it, add 5 to both sides. So 4x equals 12. Divide by 4, and x equals 3. Final answer as an ordered pair is 3, 5. Working on number 15 now. We're looking to solve this through elimination. So we need something that cancels. You could multiply the top one by negative 4, which would create a negative 8 to cancel the positive 8. Or you could multiply this by negative 3, which is what I'm going to do, which will create a negative 3x, which will cancel with this. Make sure everything gets multiplied. So this is negative 24y. And we need a 3 times 29, which is 87. It's 2 negatives make a positive 87. So now I'm combining this equation with my first one. I got to be careful. Don't jump back to this middle equation. Okay, we're going from the first one and the third one. 3, negative 3 cancels. 2 and negative 24. It's going to give you a negative 22y. And you're going to have negative 21 plus 87 gets you 66. Divide by negative 22. Y equals negative 3. Go back and plug it in. And go to my second one. X plus 8 instead of y, negative 3. So that's negative 24. I got to add 24 to get x by itself. So x equals -5. Final answer as an ordered pair, -5, x first, -3. All right, and 16 now. Nothing easy about this one. Nothing I can multiply to create the other. So I'm going to have to multiply these by each other. You can choose the x's or the y's. Since they're smaller, I'm going to go with the x's so the numbers don't get too big. Multiply by 14 here and 12 here, which will create x's that cancel. I already have a positive and a negative, so I don't need to add any negative out here. I want them to stay one positive, one negative. So 14 times 12, I get 168x when I distribute here. 14 times 60, mean -840y. And 14 times 12 we already did is 168. On the bottom, 12 times -14 will be -168x. The whole reason I chose these two numbers was to create this cancellation. 12 times 70 is positive 840y. So we're going to have a double cancellation here. So this is either going to be a no solution or an infinite number of solutions, because this whole side is going to cancel, leaving me 0 after I put them together. I got to see what happens here, though. 12 times -14 is -168. So x's, one positive, one negative, cancel. Y's cancel. So 0 is in that placeholder spot. And these cancel as well, giving me 0. Okay, 0 does equal 0. That's a true statement. So my answer here is infinite solutions. Okay, 17 now. We're going to use these skills to solve some word problems. So we have high school A and high school B, separate trips. High school A has 1 van, 8 buses, 360 students. So that's a 1V plus 8 buses equals 360 students. So we don't know how many are in the van or the bus, and we can't figure it out right now. But using same or similar sized vans and buses, as it says later on, School B used 10 vans and 6 buses, and they were able to bring 418 students. So now we can solve for one of these. We're going to do it through elimination, I think. If you wanted to minus 8b from both sides, you would have v by itself. It would say v equals -8b plus 360, and then you could take that and plug it in for v here. That's substitution. I'm going to solve this through elimination. I'm going to multiply by -10, which will create a -10v, create a -80b, and a -3600. These will cancel. I get -74b, and 418 minus 3600 is -3182. And I'm going to divide that by -74, and I get a negative, and a negative gets me a positive, so B equals +43. So that's how many students fit on the bus. They want you to find the number of students in each van and bus, so the bus is 43. You go back to one of your original equations, you plug it in, you solve for V now. So I'm going to pick the first one. It's V plus 8 times B. B I'm going to substitute in the actual number of 43. So 8 times 43 is 344, which I will subtract off the 360. And that will leave me 16. And so these are my two answers. 43 on the bus, 16 in the van. Okay, 18. These two people are selling wrapping paper. You can get plain wrapping paper or shiny. So he sold 9 rolls of plain. So I'm going to do 9p. And 12 rolls of shiny wrapping paper. Since my S's tend to look like 5s, I'm going to choose W for the shiny. That came out to $309. The other person only sold 1 of each. So 1p, and 1w, and that cost $28. So what is going to be the cost of each? This one we could use substitution if you wanted to, minus w to this side and then go plug it in. That'll work. Or you could multiply this whole thing by -9 or -12 and get some things to cancel. For the sake of this, I'll do it a little differently than we just did the last one. So I'm going to minus w over here. So p equals 28 minus w. So since that's what p equals, I can come up and substitute that in for p using substitution. So 9 times, so instead of p, I plug in 28 minus w. And this may not be the most efficient way. It may be better to use elimination on this one. But I just want to make sure that we show it both ways, so you know that both ways always work. 9 times 28 is 252. Make sure you distribute the 9, so minus 9w. Variables are on the same side, so we're going to put them together. That's going to be a 3w. This is a positive 252. If you like to leave it in front, that's fine. So minus 252 from both sides. 57. When you divide by 3, you get w equals 19. And so that is the shiny wrapping paper. It costs $19. The plain, I got to go figure out. Well, I'm just going to plug right into this first one right here. P plus w is 19 equals 28. So if I minus 19 from 28, I'm left with p, which is $9. Okay, last one. So we're planting rose bushes and geraniums. $37 total. One rose bush, I'm going to call that R. 4 geraniums, so 4G. Total of 37. And the other one, 8 rose bushes, 5 geraniums, total of $107. So you could minus the 4G like we did up here and have R equals and plug it in. I'm going to go back to the old way of doing it here, though. I'm going to multiply by -8 to create a -8R. Distribute to everything. So that's -32G. And this is going to be a -8 times 37, 296. So now when I stack these two up, I have things that cancel. The R's will cancel. So this is -27G. And 107 minus 296 is -189. Divide that by the -27, I'll get a positive 7. So G equals 7. Geraniums cost $7. And go back to either one of these equations that you want. I'm going to go back to the first one. So R plus 4 times G, which is 7, equals 37. So that's 28 minus 28, and R equals $9. So the rose bushes are $9.